Hello and a big warm welcome to this week's Certificate in Renewable Energies. This week, biomass. Well, we've dealt with the sun, we've dealt with the rain and we've dealt with the wind. Let's bring all three of them together for this week's show, timber. And we're off to talk to someone who knows a thing or two about forestry. Well, Sean, here we are in the middle of a forest. Admittedly, it's raining and we've been waiting a while for this, but tell us about this particular forest block.
Well, this is Keen Block, situated out near Nightcaps. It's an ex-farm site, so it was quite a fertile forest. It was planted in 1994, I believe. Eucalyptus nitens, that's the main crop we plant. It's a pulp crop, so we're not interested in saw log, it's just for pulp and paper production. Planted at about 1,050 stems per hectare. It's basically just plant and leave, yeah, we harvest after about a 15 year rotation.
Why this particular eucalypt?
Basically for its properties, like they did trial a few different species down here in Southland. There was Eucalyptus nitens, a species, along with they've tried Fraxinoides, Delicatensis, and a couple of others. Just at the end of the day, they found that nitens performed the best out of all of them for the climate and also for the properties. Like it gave a reasonably high yield for pulp production. So yeah, it turned out to be the best species really for the job.
Take us from the beginning, the seed, what happens, how do you select the right seed, that sort of thing. Things people don't really think about as far as forestry goes.
Well, we collect all our own seed. We have a seed orchard, which was established by us basically through genetic trials. We want to select the properties in the trees, like obviously better yield, form is important to us, easier for harvesting, and yeah, just your general growth properties. So they test it, like you want to get your good properties. They'll plant out an orchard, so basically you've selected your best trees that you want the properties for. On that you should hopefully get like seed a few years down the track, which, you know, with mother and father combined, you'll get those good properties coming through in the genetics. We collect that, we'll extract the seed, do germination testing to make sure that you know, the seeds are viable. If it's good, then we'll send them away to nurseries to be reared up till they're about half a year old, just seedlings. Those seedlings we use to plant out the next generation crop. So two different types of seedlings. We use containerised seedlings, which is basically they're in a little pocket of dirt, and then there's plug plus ones or bare rooted stock, which are more or less just ripped out of the ground, the roots exposed, ready to be transplanted straight away. Obviously you have to do it within a few days, otherwise the trees will suffer. But yeah, the bare rooted, it's good for earlier in the year, like you tend to be a bit larger, they'll handle replanting no problem, and then the containerise, which has got some dirt around them, it can be later on in the growing season when the trees start flushing or start putting out new roots. This is generally around spring, obviously, so yeah, just if the planting season takes a bit longer than we expected, it's good to have some containerised stock just for the conditions.
Now, planting trees for timber, of course, is a bit different. You plant them, you come back and prune them and that sort of thing and thin them out. What's the story here? Do you plant a few and then come back and thin them out and then prune it all?
Yeah, well, we're a bit different to saw log production. Like I said earlier, it's just pulp production, so more or less we plant out at a reasonably high stocking. We were planting at 1,050 up to 1,200 for the more fertile sites. We recently have started planting at 900 just to basically get fatter trees. We think we can still get good volumes if we plant slightly lower. So yeah, we plant it and leave it 12 to 15 year rotation, no thinning, no pruning. Like at the end of the day, it's just going to be going to the chipper, so not interested in saw log at this stage.
The problem with pines also is that nothing will grow underneath. Do you have to clear up under these forests to make sure the trees are uninhibited?
Oh yeah, that's quite an important part of an establishment. With land clearing, we are getting into our second rotation crops. We haven't got any new farms we're establishing. So we'll either root rake, which is clearing up all the branches and slash into heaps, or the other alternative is to burn the slash and clear it that way. And after we've done that, we'll do some cultivation if necessary. If the ground's been compacted or the soil's shallow, things like that, we'll rip and mound. Just basically, it's like cultivating your own garden.
On a huge scale?
On a huge scale, yep. Break up the soil so it gives the tree a chance for its roots to spread and establish itself effectively. Once that's done, if there's any areas that maybe need ditching or mounding, like wet areas, then we'll do that just to improve drainage. The trees here don't like wet feet, they won't grow well. Once that's done, we'll do a pre-plant spray just to remove any unwanted grasses and other obnoxious weeds, gorse, broom, that. That's usually done about a month before planting, a month to 2 months, just to give a chance for the weeds to be killed off, and also if there's any residual spray left, it'll get washed away and won't affect the growth of the new trees. Once that's done, usually about July we'll start our planting season. The reason we do it in the middle of winter is just the plants are inactive at that stage, they're dormant over winter, so it's less of a transplanting shock for them. That usually lasts, depends on how much you plant, but we've been planting roughly, at the moment we're planting about 400 hectares a year, so it doesn't take too long depending on your planting crews. Once that's done, usually in about September or so, we'll do a post-plant spray for the previous year's plantings, just to control that weed growth again. And if there was any areas that couldn't be sprayed pre-plant, for whatever reason, we'll go around the planted trees and we'll just do spot spraying, which is like it explains itself. It's just a spot around the tree just to remove that competing weed growth. Then once you start getting to spring, the trees have sort of been planted. We'll go around and we fertilise all the new planted trees. Nitrogen-based fertiliser, usually something like diammonium phosphate. Roughly, we've been working at about 120 grams per tree, but then again, it just depends on the soil type and determining the fertility of the soil and that as to how much fertiliser we'll give them. But yeah, on average, it's about 120 grams. So yeah, it usually kick-starts the trees and gets them growing. So
They are very fast growing eucalypts, aren't they? I mean, all of us have probably put one in our garden and been astounded a couple of years later by how big they are.
yeah.
How old are these trees that we're standing under?
These are about 14 years, I believe. Planted in 94, so yeah, 2008, just coming up to 14 years. Yeah, you'll get a wee bit of variability, but generally speaking, the trees do grow fast. That's one of the properties that's so appealing for the pulp and paper industry. We want a fast-growing, high-yielding tree, so high production. But our new generation that we're planting now, they're talking to some of the staff that have been here for a while and seen the first generation grow and the new generation coming up, They're saying how much faster you're growing now, like it's just improved seed stock, and yeah, they just seem to be very vigorous. I mean, the climate, as you can see, is pretty conducive to growing trees.
Yes, well, it has been a while. We've been waiting for this rain over the summer down here and in the rest of New Zealand fairly much. Were you worried at all about these trees?
Yeah, well, sort of getting into drought conditions, it is a bit of a concern. The trees are reasonably hardy,
And Australian.
and Australian, yeah, they're pretty good at surviving these droughts and things. Probably more of a concern to us is not so much drought, but frost tolerance. We have had issues with frosting with these trees in the past. It can kill the trees off, even as old as 3 years old, that'll damage the trees. Back in 1996 we had that really cold snap in winter, and yeah, we lost a few trees and gullies and that, and just frost hollows. So
Our friend the possum, deer and goats, etc., do they have an impact on these forests?
yeah, we've really got to keep up our pest management strategies. Probably the main thing would be rabbits and hares, but also, yeah, goats, deer, they love browsing our trees. Possums also an issue. Things with possum control, luckily we're part of, with the Area Health Board, giving out contracts for TB control. They cover a lot of our blocks just as part of the area, so we pay levies for that, and it saves us the hassle of having to do it. And blocks where there, we'll monitor that annually, and if there's any blocks that have been missed in those contracts for that year, we'll get our own private contractor to go through and do possum control. Other than that, yeah, more just the blocks we planted in the last year or two, we'll just be constantly monitoring. If there's a problem, then we'll have some form of control.
These trees are obviously very near harvesting. What happens in the harvesting process? Do we still see people in the forest with chainsaws?
No, it's pretty much all mechanised these days. We've got a couple of harvesters, owner-operators that harvest our blocks. Basically diggers with processing heads, they're called waratahs. All they do is they basically come up with your digger, clamp onto the base of the tree. This processor has a couple of chainsaws that can cut the tree down, they'll pick it up. They can delimb and debark just with a couple of sweeps of this machine, and they cut it into 6 metre lengths. They'll lay it out in lines, leave it to dry for a month or so, just to remove some of that moisture content, more economical for transport. Then we'll get a forder coming along, basically a machine that will just pick up those logs, put it into like a wee crane, put it onto its tray at the back and forward it out to the roadside. And it's just a matter of shipping it off down to the chip mill. You
mentioned that this was previous farmland. Is there competition with beef, sheep and even dairy farming for the land?
Yeah, I believe there'd be a lot of dairying people out there that see the land and would love to see it converted back into dairy land. But yeah, the problem is a lot of our forest is post-1990, and with recent legislation now, if we were to convert, not saying we would, but if we were, then it would end up costing us, with the current tax, about $14,000 a hectare, and it's just not economical. And at the end of the day, we're here to grow trees, we can look at alternative land uses, but with the way carbon credits and things are going, there seems to be more interest in planting trees as well, and to offset that carbon emissions from dairy farming and so forth. So yeah, there is competition definitely out there, but I mean, at the end of the day, I think these trees are going to be here to stay for a while.
So Kyoto's always in the back of the old mine there with the carbon credits and that sort of thing?
Yeah, well, there's still a bit of uncertainty out there about how it's going to work, and certain profitability, I guess. But yeah, I think there's definitely going to be some future for it, and I can see a lot of money being made through carbon credit trading.
And here in Southern, you've spread out your plantations. Has there been a reason for that?
Yep, there was a wee bit of a land grab, I guess, at the start. They were buying up farms to build up the estate. We're aiming for about 15,000 hectares, I believe. We currently manage about 12,500 hectares. They were planting at about 1,000 hectares a year, just so by the time they got to that 15-year stage, it was always planned, they'll carry on into their second rotation and be able to carry on. So Yeah, and also spreading it out, it does, minimise your risk a bit. Like if there happens to be, I don't know, a drought event or a heavy frosting or whatever, like if you have a range of elevations and geographic situations, then you're going to minimise your risk. So yeah, the main thing for us though was to keep it the chip mill where all the processing was done. Like you couldn't obviously have your plantation too far out, or the economics of it just were no good. Too much cost and transportation, etc.
Trees really a great renewable resource, and of course they're off to be made into paper, which again can be recycled as well. That must be quite a good feeling for you.
Oh yeah, it's we try and give that clean green image, and renewable resources are the way to go for the future. Yeah, if people just sort of, then a lot of people have negative thoughts towards forestry and that, but at the end of the day, we will have different land uses, and we try and make the world a better place in some form or another. So yeah, recycling and renewable resources, it's got to be the way to go.
Well, Sean, thanks for enlightening us slightly on the science that is, in fact, growing forests.
Yeah, no worries, a pleasure.
Well, we're going all the way from the depths of a southern eucalypt forest to Dunedin, where we're going to speak to a gentleman who's invented a rather environmentally friendly way of burning wood. Okay, Malcolm, well at home I've got a primitive open fire. What's the difference between that and your invention here?
Well, this one's an automatic system. I mean, you have a little motor here which augers your wood pellets along, and it's burnt in what is called a burn pipe. You've got a blower here so you can adjust the fuel to air ratio correctly. So as you can see, it's smokeless, right? The trouble when you run it home, you can't control the air to fuel ratio, and then you get smoke coming up the window. Basically, smoke is when it's not getting enough air, right? And it's like running around in your car with a choke out and it's smoking. With these ones here, you can set it perfectly. Also, to get a high combustion temperature is required also to get it clean as possible as well. In normal fireplaces, you can't get a very high combustion temperature. They are improving them with ceramics. This one here, when it goes into the boiler, usually rise up to around about 1,000 degrees, and with the right fuel to air ratio, it's absolutely smokeless, right? It's clean as gas or any other appliances has automatic feeding.
What first got you interested in this? What first got you into designing this?
This is basically a automatic coal stoker, and it's evolved from that because the same engineering is used in automatic coal stokers, which were developed about 1930. So it's just evolved from there, and people started making pellets and they sort of stuck them into automatic coal stokers and then sort of refined them from there. This one here has an electric start, so it comes on automatically and it will shut down. So there's quite fancy electronics to adjust everything and have everything running perfectly, the right fuel to air ratio. It can cut it down to low, medium or high, depending on the demand of the house and the temperatures.
So you're heating the water, basically you're heating the water that heats the house.
Basically, this is the engine from the boiler. It heats the boiler, which the water then is pumped around the house, either through radiators or modern ways to put underfloor heating, just the pipes and the concrete, which heats your house. It also heats all your hot water. Some people use them for heating spas and swimming pools as well. So it's a total heating package, not just the heating, but all your heating in every room as well, all central heating and all your hot water and anything else you need to heat.
So that's one unit for the whole house?
Yes, one unit. The units I bring out are quite powerful. They're a 30 kilowatt boiler, which is the same as 31 bar heaters. So they're very powerful, and most of the people who buy these have got houses 200 to 300 square metres, they've got big houses, and they need a lot of heat to heat them. And they can do that with one of these units, one single unit.
And the fuel itself, the wood pellets, are totally renewable?
Yes, it is totally renewable. The wood pellets, I mean, they're in Invercargill is a plant. There's another plant in Christchurch, and there's a few plants up in the North Island. They use just spinnings and any old scrap wood, and they grind it all up and then push it through as pellets. And the pellets are very, very high in energy. You've got 2 kilograms of the wood pellets is the same as a litre of diesel, so there's a lot of high heat output, and it's amazing how much heat you can get out of a bucket of pellets. They're really, really efficient and very, very clean. And of course they're produced locally. My main competition is diesel, which is imported, right? So on an economic basis, it's cheaper than imported diesel, as well as environmentally. So yeah, it is very good. In Europe, it's big because central heating over in Europe is very big, and it makes sense to replace bringing in imported diesel and use local fuels, which are environmentally friendly and renewable. Right, so it's really taking off in Europe and in North America. But slower in New Zealand, we're always a bit behind the rest of the world.
We're bombarded with advertising for electric alternatives for heating your house. How does it match up?
There is a problem there. I mean, you have multinational companies with big marketing budgets coming in, and they're able to have TV ads and using electrical appliances to heat your house. I mean, the problem is, we don't have enough electricity, and it has to be generated using fossil fuels because we don't have enough renewable electricity, and the demand is increasing so greatly that it'll never catch up. So I'm up against that. I'm up against the multinationals with big marketing dollars. And of course they're pushing their product, but they use electricity. Electricity is a very inefficient way. I mean, they lose 70% of its heat value. When they use coal or gas, the process loses at least 70% time it's generated through the lines. The time it gets to the house, it lost 70% of its energy. So it's a very inefficient way of heating homes by using electricity.
Just before we head over to the finished product, let's have a look at the model or prototype here. How is it for maintenance? There's a few moving parts, and also clean-up. We all know with open fires it's a very messy process. Is there much waste product with this?
What you're talking about is ash. There's a 1% ash. It's been very easy to handle with the ash with these because I'm used to coal, and you get a lot of ash with coal. So I've got the mechanisms, big ash pans and that sort of thing to make it easier. I mean, every 2 or 3 weeks you'll need to take that pan out. The rest is all automatic.
It's a bit better than every second day with a fire.
Well, I mean, unfortunately it's still in that stage. I mean, they have got really flash ones in Europe where it's every 6 months to clean it out, but I haven't developed that at this stage. So, I mean, most people are quite happy just to take an ash pan out and put it on you can put it in the garden every sort of 3 weeks, and there's not really
where it breaks down and helps the garden.
Yeah, so they use it as fertiliser.
Sure.
So it's pretty around. Yeah.
Okay, well let's go and have a look at a finished product. Well, Malcolm, the finished product, it's fairly impressive, isn't it? But it's not designed to go in the living room, is it?
No, most people put them out in the garage, or they'll have a dedicated boiler house. They'll put them in, but no, they don't go in the house as such. I mean, this is quite a powerful unit. It's a 30 kilowatt unit, and it needs to be out in the garage, or preferably in a little dedicated boiler house.
Do you think people are educated enough in these alternative methods, or do they simply, you mentioned the big advertising before from companies, do they get overwhelmed by that? Or are you noticing people taking a lot more interest in this sort of thing?
Well, I mean, the markets, these traditionally been diesel, right? A lot of diesel, a lot of heating is done with diesel. And to bring in renewable fuel source, I mean, it's a long time before people change over from fossil fuels to renewable fuel source. So, I mean, it's big in Europe and in North America. It takes a while for New Zealand to change attitudes and change behaviour. I mean, but wood pellets are competitive against diesel now. Diesel's up around the 14 cents a kilowatt unit, where you can get the wood pellets at 8.5 cents. So on an economic side of things, the figure's way up. So that will be a big plus when people make a decision to go renewable fuel source.
And electricity's going up all the time, of course.
Electricity's going up, I mean. In some places they're paying up to 24 cents a kilowatt unit for electricity, and it's rising. And the beauty about this is that they heat the hot water, which is a big plus for people, and they want to heat all of their house, and they can do that with a wood pellet boiler.
Well, let's take a look inside the unit.
What we got here is just this is the engine part of it. It's just a basic boiler, right? It's just insulated, and you've got you were talking about the ash before. There's a special ash pan that can drop down, and it just comes out. So it's got to be very. I have a lot of women end up using these, so it's got to be really user friendly and all automated as possible. So I developed it over the years to make things as easy as possible from customers. So this is the latest model with all the new features.
So obviously highly insulated. So this is where the heated water's contained and distributed throughout the house.
Yeah, well, it heats up the water. There's thermostats that'll shut the water off when it gets up to temperature. When the house calls for heat, there's a circulation pump that comes on and pumps the water around the radiators or around under the floor. As soon as the house is up to temperature, it turns off the circulation pump, and then the boiler turns off as well. So you're not using any more heat than you need, so your efficiency is higher. And because it's got a timer, it comes on exactly so when you come home from work, it turns on, or when you get up in the morning, it's already hot in the house. So it's fully automated like that. I mean, and that's what people want. They want fully automation.
Well, Malcolm, thanks for sharing your invention, if you like, or innovation with us, and all the best for the future. Well, a big thanks for tuning into this week's Certificate in Renewable Energy. If this course, or any other for that matter at SIT, strikes your fancy, then please call 0800 SIT to learn for more information. We'll look forward to your company next show. Hi, and a big welcome to this week's show, Biomass Renewable Energies. Now,
Actually, we need to get a proper